This lecture is about the mixed ANOVA. Now, just so we're all clear, we already mentioned briefly what a mixed ANOVA is, but as a review, I want to remind us that a mixed ANOVA is when there is at least one independent variable or one factor that is measured as between subjects. And as you know, between subjects means there are different groups of people, that the levels of the independent variable were only given to across people, between people. They weren't given to the same people in repeated measures. Instead, like, you have some men and some women, and they were only one or the other in the study. Of course, you also have to have one independent variable or one factor that is within. And by within subjects, we mean that these are repeated measures, that these are measured within the same people, that you might have like you might have like lighting conditions being high light, low light, and completely pitch black, and those would be the levels of your independent variable of lighting. But you would have the same people in each of the conditions. You'd try them in the bright light, the dim light, and the no light, something like that. You can have more than one independent variable that's between, more than one that's within, but you have to have at least one of each. That's what means mixed, that there's at least one of each, but you have both kinds. Now, just so we remind ourselves, what does it mean if I say we have a two-way mixed design? If you need to, pause your video for a second, think about that. A two-way mixed design is when you have two independent variables or two factors, and therefore one of them would have to be between and one of them would have to be within because it's mixed. So you have to have at least one of each. That means a two-way mixed would be one between, one within. What about a three-way mixed design? Well, that would mean you have three independent variables, or three factors, and at least one of them would be between, and at least one of them would be within, but you would necessarily have to have two of one and one of the other. Because if it's a mixed design, that means you have to have at least one between and one within, but the last one, the third one, could be either one of those. Now, I want to go through an example of a particular situation here that we've imagined to ourselves as a speed date. As we do this, I'm going to articulate the independent variables, the dependent variables, and kind of set up the scenario for us. So let's say that our research question was, is personality or looks more important? Let's say that you collect a bunch of your friends to act as Confederate dates with varying levels of attractiveness and charisma. So this group of people that maybe you know from the dorms at school or from classes at university or whatever, you grab these people, you put them in a room, and they sit around the edges of the walls. And then you also bring in participants to be the people who interview those potential Confederate dates. So you've got you've already pre-rated the attractiveness and charisma of these people who are your Confederates. You've maybe gone through some other preliminary exercise where you have them ranked, rated, stuff like that. And so every one of your Confederate dates has a particular attractiveness level and charisma or charm level. And you have a couple of different independent variables in this study. The first one is looks. You might ask, is the date attractive, average, or ugly? So you've just rated them as one of three levels. So these Confederates are either attractive, or they're average, or they're ugly. The second independent variable is personality, and you might say then, does that date have high charisma, some charisma, or are they a dullard? No charisma at all. So again, these Confederate dates, they've been rated on charisma as well. They have a high, moderate, or low amount. And then the third independent variable is actually not about the individual the Confederate dates, but about the participants themselves. Is the participant male or female? Now, before we move on to the dependent variable, I just want to think through here for a second whether these would be within or between independent variables, whether these factors are measured between or within. So let's take a second and have you pause your video and consider for yourself which you think they would be. Now, this is a little bit of a tricky exercise here, and the reason why is because in a speed dating situation, what you've got is individual participants coming in and meeting with multiple dates, right? They sit for 5 minutes with one, and then they switch to the next person, and they switch to the next person, they switch to the next person, and so each participant in your study is going to be meeting with multiple dates who are attractive, and multiple dates who are average, and multiple dates who are ugly. They're going to also be meeting with multiple dates that have high charisma, multiple that have some charisma, and multiple that are dullards. But each of those participants is only going to be a male or a female. They're not going to be both. They're not going to swap. So as the date come in, you'll meet with people around the edges of the room who are presumably your opposite sex, but perhaps depending on the speed dating situation, the same sex, and you will be rating you will be experiencing the date based on your own sex, as well as the attractiveness level and the personality level of the person sitting across from you. So these two variables are within subjects independent variables, and this right here is a between subjects independent variable. And then at the end of the date, you're going to rate how much you enjoyed meeting with each of those people. And you could rate them on a scale from 0 to 100, where 100 is the prospective date was absolutely perfect, and 0 was I'd rather date my own mother. Just absolutely abysmal, terrible, terrible date. Okay, so let's say that this is our dependent variable. These are 3 independent variables, and let's switch over to Jamovi. Okay, so the way we've got the data set up here in this file is we've got all the variables across the top. Only the first one is the between subjects variable. This is a list of 10 male participants and 10 female participants, and each of those people went across dates that were of varying levels of attractiveness and charisma, and rated those individuals on a scale from 0 to 100. So just if I double click here, you can kind of get a sense for what this variable is like. This is ATT, meaning attractive, and high, meaning charisma, like high charisma. So this is a very attractive and highly charismatic individual. If you just kind of glance across these numbers, you can see that they're relatively high, as you might expect, that if somebody who was both attractive and charismatic would have very high ratings. You next have somebody who is average looks and high charisma, and then finally you've got somebody who is ugly with high charisma. Then you've got attractive some, average some, ugly some, and finally you've got attractive, no charisma, average, no charisma, ugly, no charisma. So you've got 9 different combinations of characteristics of attractiveness and charisma. And so as you look at those different combinations in conjunction with each other, you end up with all the possible groupings of those 2 independent variables. And the way we deal with this, as you no doubt remember, is by going to the ANOVA function and choosing the repeated measures ANOVA. Now, in addition to putting in your repeated measures variables, you're also going to put your between subjects factor in the list here, where it says between subjects factors. So just to kind of get that out of the way first, I'm going to take that and I'm going to plop it over here as our between subjects factor. Then we have to figure out, what do we do with all of these repeated measures designs? We have 2 factors, remember, looks and personality. And so I can start here with calling the first one looks. And this has, of course, 3 levels. We've got attractive and average and ugly. Then we've also got a second repeated measures factor, which is charisma. And within charisma, we've got 3 levels as well: high, some, and none. So I'm going to label those like that: high, some, and none. All right, so that fleshes out for us a list of combinations: attractive high, attractive some, attractive none. average high, average some, average none, ugly high, ugly some, ugly none. Now, because of the order I've put these in, they don't match up perfectly with these variables over here. If I had put in charisma first and then looks, then you can see that it would have fleshed out for me a list that was in combination as the exact same order as my variables were over here. But as it is, I'm just going to take these 3 attractiveness variables, high, some, and none, and I'm going to put them over first. You can see that where they put them was attractive high, attractive some, attractive none, so they match correctly. Then I'll take my average variables. I'm doing this by holding down the control button and just selecting the variables I want and plopping them over. And then finally, in order to get the ugly high, ugly some, ugly none, I just take all 3 of those and plop them over as well. So now I have fleshed out all of my combinations of repeated measures variables in this box right here, and I have also included my between subjects variable, and therefore I have told the computer everything it needs to know in order to run an ANOVA. And you saw that immediately as soon as I finished putting in all of the repeated measures variables, it ran the ANOVA for me. But in order to know whether it's safe to interpret these results, the first thing we have to come over here and do is check our assumptions. We need to run some sphericity tests, and we need to run some homogeneity of variance tests. Now remember, sphericity and homogeneity are basically the same thing, but sphericity is for repeated measures variables, and homogeneity of variance is for between subjects variables. And so we're running sphericity for all of these ones here, and we're running homogeneity for this variable here of gender. So let's go down and look and see what we've got going on. As you can see, your p-value for all of these Mauchly's W's are not significant, which is a great thing in this situation because it means that you don't have different sphericities across the variables. If you look down here at your homogeneity tests called Levene's tests, your ANOVAs are all not significant, and you can tell that by looking through your p-values. None of them fall below the value of 0.05. So again, that means that you don't have any differences in variability across the different conditions. They all have approximately the same amount of variability, which is really good for your statistic. That's what you're assuming is going to happen. Now, if you had violated these assumptions in a more advanced statistics course, you might consider other non-parametric versions of a test that you could run, or you could consider doing things like bootstrapping, or you could you could try what's called transforming your variables to try and force them into fitting certain assumptions. But in this situation, thankfully we haven't had any problems, and even if we had in this class, because of the relatively rudimentary level of statistics that we're trying to learn, we're just going to be focusing on maybe interpreting those statistics with caution, kind of equivocating a little bit more, saying we violated some assumptions of the statistic. We think the statistic is probably robust enough that the conclusions are still accurate, even though we violated an assumption. So we'll just go ahead and still run it, but we can't be certain that these findings are 100% trustworthy. So you'd say something like that in your write-up. But here we don't have to because we haven't violated assumptions. Yay! Now I've switched back to the PowerPoint for a second because I just want to remind us that we've got a few things going on here when we run an ANOVA for a factorial situation where we've got multiple independent variables. Of course, we know that we're going to be running an ANOVA to test whether there are main effects. We have 3 variables: looks, personality, and gender. So we're going to be running an ANOVA test on each of those to see if there are any significant differences across the levels of looks, across the levels of personality, and across the levels of gender. So in other words, asking, are people who are highly attractive, moderately attractive, or ugly, are they different in their ratings? If we look at personality, are people who are very charismatic, moderately charismatic, or complete dullards, are they different in the ratings they get? And do males and females give different overall average ratings to the people that they're speed dating with? That's the question that we'll be asking with those 3 F ratios that are computed for to test the main effects. But then we're also going to be running some additional F tests. We're going to be running three two-way interactions. So we're going to be looking at the interaction between looks and personality, looks and gender, and personality and gender. So what's going on here is we're trying to see, are the levels at which, are the ratings that people give based on looks different for the levels of personality? So like, if you have an attractive person, does it depend whether they have high, average, or low charisma? If you have a moderately attractive person, does it matter whether they have high, moderate, or low levels of charisma? So again, we're just looking at, do the levels of one independent variable matter when interpreting in light of the other independent variable? And if they are, then you will get a significant interaction where you'll see that, again, like I mentioned in previous lectures, that the lines that you're plotting cross, or they're not parallel, that they have different slopes, for instance. And when you find that kind of thing, then you have to say, okay, what's going on here is that the levels of the one independent variable influence the behavior of the other independent variable on the dependent variable. So I'll get into some more concrete examples as we interpret these interactions. But then we also have a three-way interaction term that we have to interpret for this situation, because we're going to run an F statistic to see whether looks and personality and gender all interact with each other. And if that is the case, then we can then we have to kind of interpret these other two-way interactions and these main effects with caution, because it's unlikely to be a true full story when you look at just the two-way interactions, because all three of the independent variables depend on each other. All of them influence the behavior of the others when you're looking at how people enjoyed their date, if that were a significant F ratio. So hopping back over here to Jamovi, you can see the different ANOVAs that I just described we would be looking for. So you're going to find your three main effect ANOVAs, which are listed as looks here, charisma here, and gender down here. Now, the reason gender is in its own little table apart from these others is because they've separated your within subjects effects from your between subjects effects. So you have to look separately for those that are between subjects as opposed to those that are within subjects. So looks and charisma are within subjects, then gender is between, and you can look at each of those and see that there's an F here listed at significant less than 0.001, an F here for charisma that's listed as, again, significant at less than 0.001, but the gender effect is not significant with a P of 0.9. So overall, men and women did not rate their dates as more or less enjoyable than each other. However, if we look up here at the looks by gender interaction, that is significant. And the charisma by gender interaction, again, that is significant. And finally, and I'll just stop there for a second and say what that means is, even though men and women didn't rate each other differently overall, didn't rate their dates differently overall, they did rate them on different criteria. So looks mattered a different amount to men and to women who were rating their dates. Charisma also mattered to different levels to men and women who were rating their dates. And the reason why we know that is because the levels of looks depended on gender. The influence of charisma depended on gender. And then finally, we can also see this other two-way interaction, looks by charisma. That also is significant at less than 0.001 p-value. And that suggests that, again, the levels of looks and charisma differed from each other, so that they had differential impacts on people's enjoyment of the rates. So we'll look at specifically how that was in some line graphs later on, but we can assume that your attractiveness level depends on how much your attractiveness level impacts the enjoyment of the date depends on your charisma. And similarly, how much charisma matters in your enjoyment of the date depends on how attractive you are. So we'll look at kind of that interaction there. And then finally, there was a significant looks by charisma by gender interaction. And when you, and the reason, again, why we know that is because the F value is far greater than the null hypothesis expected value of 1, and it's less than 0.001 as a p-value. So we can say, oh, there's a three-way interaction, meaning that the levels of looks and charisma and gender all depend on each other. And again, we'll look at how that kind of interplay functions as we graph out some different line graphs. So let's move there next. Let's scroll down here and we'll click under estimated marginal means to get our graphs. Now the way we ask for graphs is to get these as it's checked right here where it says marginal means plots. So we want these to be graphing some plots for us. So if we look first at the looks by gender interaction, we can request a looks and hold down control gender, and so you highlight both of those by holding down control and you bring them over to this box, and it tells the computer I want a looks by gender graph. If we scroll down here, you can look at the differential slopes of these two lines. They cross, they're different slopes, and because the interaction up above was statistically significant, we can say that the impact of looks on your enjoyment of the date depended on whether you were a male or female. So men rated attractive dates far more highly than women did, and men rated ugly dates as far less enjoyable than women did. So what we've got here is women more evenly across the board, not perfectly, but more evenly across the board, rating their dates as approximately equivalent regardless of how attractive they were. They give a little bit of a bump for more attractive dates and a little bit of a drop for less attractive dates, but all in all, women don't care about looks as much as men do. That's how we would interpret this graph. Men care a lot about looks because the attractive dates are getting really high marks and the ugly dates are getting really low marks. But females, that isn't quite so extreme. Okay, well, let's look at another interaction. So scrolling back up, you can see here that we've got the charisma by gender interaction. So let's take charisma and gender. We'll highlight both of those, plop it over here onto the we need to add a new term, so we're adding another kind of graph. So we're going to take charisma by gender, highlight both of those, put it over, and it's going to give us a new graph. So this charisma by gender graph is suggesting that females are, in this situation, responding kind of the opposite as the males did up here. So females are caring a lot more about charisma than males are. Females are rating their highly charismatic dates as off the charts, and their dullard dates they're rating as very, very unenjoyable. But men, they don't seem to care as much about the charisma of their dates as women do. They get a little bit of a bump here if they're highly charismatic, and a little bit of a drop if they're a dullard, but it doesn't seem to matter as much to men how charismatic the dates are. Okay, another thing we want to look at, we go back up here, we have another two-way interaction, which is the looks by charisma interaction. So the way we would get that, again, is to highlight both looks and charisma. We add a new term, asking for a new graph, and then we plug them both over at the same time. It will give us a looks by charisma interaction graph. And there's a lot going on here, but I'm going to try and break it down a little bit so that you can get a good sense for kind of how to interpret this. Well, one thing you need to remember is that right here, we're not looking at the impact of gender. This, so far, is only looking at charisma and attractiveness. So, like, men and women is removed from the equation, and we know that they play an important role here, so it's important that we kind of interpret this in a hesitating fashion. We're going to look at the the interaction between these two variables and gender also in a moment. But right now we're just looking at the two-way interaction between charisma and looks. So if you look at the people that have high charisma, they're this blue line right here. This blue line means high charisma, and it seems like if you have high levels of charisma, the overall levels of enjoyment on your date are pretty high. They're like 75 to 90, no matter how attractive you are. Even if you're ugly, if you have high charisma, it makes up for a lot. Like, you can still have a 75 rating date if you were ugly but still had high charisma. So that's a good thing. Like, you can make up for being unattractive. Another thing that we should note here is that those people who have no charisma, this is that orange line, you can see that those people who are ugly and have no charisma, you are doomed, sorry. If you're average and have low charisma, again, you don't, like, there's not much going for you. But you can make up for a lot even if you're a dullard, if you are very attractive and a dullard, that makes up for a lot. So people are happy to put up with your poor personality as long as you're really good eye candy. Okay, so we've kind of got a good idea of what's going on with the blue lines and the yellow lines. Now let's take a look at this gray line. This is kind of in between the two. This gray line is some charisma. In other words, these people are like nice to get along with, but they're not especially charming, but they're also not boring. They're just average. Average people have a really strong relationship to looks. So the more attractive, averagely charming people, if you're just kind of like normal and attractive, then you're gonna have a great time. People are really gonna rate your date as high. If you're just a moderate personality and of average looks, then you're just kind of like right in the middle of everything. And then finally, if you're ugly and have average and average personality, then again, you're just as bad as if you had no charisma. Like, these two here are like, they may as well be the same level. So heaven help you if you're ugly. Like, if you're gonna overcome your ugliness, you have to have high levels of high levels of charisma before you can make up for your ugliness, right? But if you are highly attractive, it's okay if you're not that if you're not that charismatic. You can be even very boring, and people will still enjoy being around you because your attractiveness is more important, apparently. Though these two things relate in a fascinating way here, where if you look at 70, across the board, you've got these 3 points that are all about the same. Not exactly, but very close to 70. What are those 3 points? These are people who are boring and attractive, who are ugly and charismatic, or who are average in both. Those 3 are rated about the same. So you can kind of draw a conclusion that one of these variables makes up for the other, or you can have them both in good measure and you're okay. So there's a lot going on with this graph, but if you kind of like just look at the different data points and spend some time interpreting it, just kind of like really drill down into it, then you start to get a sense for what's going on in the graph. It takes a while, takes some patience, but you can kind of get a good feel for why these variables are interacting with each other in this statistic that we found up above, where it says looks by charisma is interacting. Okay, well, we've looked at the interaction here that's two-way, this one that's two-way, this one that's two-way. The one that we have left is this three-way interaction, looks by charisma by gender. So in order to do that, we're going to highlight all 3 of these variables. Looks, charisma, and gender. We're going to add a new term and then plop them over here on this side and see what this graph looks like. Alright, so what we've got here is the 3-way interaction, and because each of these each of these panels of graph can really only hold 2 variables at a time, the variable that's on the x-axis and the variable across lines, those 2 independent variables have to be the only ones that are depicted on each graph. Since we have a third independent variable of gender, we have to draw 2 different graphs to depict the interplay between charisma and looks on men and charisma and looks on women. So again, still here we've got the ratings of the enjoyment of the date here on the y-axis, and we're going to start to take a look at how these interplay with each other. So, looking at the males graph, you can see that that attractive people are highly rated across the board, regardless of their charisma. If you have no charisma at all, don't matter. As long as you're beautiful, men love you. If you're ugly, charisma cannot make up for much. You do get a little bit of a peak here, a little bit of a bump here for being highly charismatic, but again, if you're unattractive, then not much. So mostly the time where charisma really matters for a male is in this situation if you are of average looks. So if you're average, then charisma can kind of make up for a bit, and if you are a dullard and average, then you're really sunk. But this is highly differentiated. But for attractive women and for ugly women, there's very little difference. Men don't care that much about charisma in those extreme situations of looks. Women, on the other hand, appear to have the complete opposite. You've got women behaving across the board, regardless of how attractive you are, behaving highly positively toward people with great charisma. You've got women not really caring at all about looks down here with very low levels of charisma. You've got just like the women do not enjoy the date across the board. No, even if you're very attractive, they just don't care. Now, where is the situation where women do care? Well, if you've got some charisma, if you're just an average personality, then looks can make up for something. So you've got really high levels of enjoyment if you're both attractive and moderately charismatic. If you're average looking and moderately charismatic, then you're right in the middle. And if you're ugly and moderately charismatic, then women don't really enjoy the date. So attractiveness matters for women, but only when you've got an average personality. If you've got a great personality, women don't care about looks. If you've got a really dullard personality, again, women don't care about looks. So men primarily care about looks, women primarily care about personality, but where it matters most is in the middle, in that average personality. You see a lot of highly differentiated ratings for both men and women. Now there's just a couple more things we need in order to be ready to write up our findings for publication. One of the things that we're going to need is to get a sense for the effect sizes that are going on between these different conditions. As I explained before, you can do that using the eta squared. There's also a couple of other effect sizes here. You can Google how to interpret them. For instance, the partial eta squared removes the variability of all the other conditions that are going on and just leaves like the percentage of variance explained after removing all the others, but it's very difficult and unintuitive to interpret that. And so I'm just asking for the ordinary eta squared because those are additive effects that are easy to interpret. And so we come back up to the original ANOVA table, and you can see you've got a new column here that says eta squared and another one here that says eta squared. And what that allows us to say is that 33% of the variability in how much a date is enjoyed can be accounted for by the looks of the person you're dating. How much an individual the amount of charisma and its impact on the enjoyability of the date is about 36%, and the amount that your own gender matters is nothing. Like, it doesn't make any impact by itself. However, as we know, the interaction between the gender of the participant and the attractiveness or the charisma level of the individuals that you're sitting with do in fact matter, and they account each for about 6 and 7% of the variability as well. So those interactions matter. And then finally, the amount of variability that the interaction between looks and charisma and gender have on your enjoyment levels of dates are about 6% of the variability and 4% of the variability. That means all the differences that you see in the original scores over here, I'm going to collapse this for a second. In all these scores, you see differences. 49 is different from 58, is different from 71, is different from 56. Why did all these different people get different scores? Well, we know that a lot of it is because of looks, a lot of it's because of charisma, a lot of it is because of the interaction between looks and gender, charisma and gender, and the interaction between your charisma and gender and looks all together. And so if you look at all of those combined, you can say that about 33% and 36% and another 6 and 7 and 6 and 4, that adds up to, I just paused to add it up, that's about 92% of the variability. So all of these scores here are different from each other, but if you know somebody's attractiveness level and their charisma level and the sex of the person who's doing the rating, then you can account for like 92% of the differences that you might see here, and the rest could be accounted for by other kinds of things, like just like the mood of the person as they were in that particular moment with that particular date, or if there was like a loud sound that happened to interrupt the quality of the date in the middle or something like that. Those are error. That's error variance. It's just stuff that you haven't accounted for, that wasn't part of your study, but still happened and still influenced people's scores. But 92% approximately of all these differences that you see here can be accounted for by those three variables, and very little is left for just luck or chance or other things that we haven't controlled for. Now, the other thing that we're going to need here is an estimate of all the means and standard deviations of all the different conditions that exist in this data set, because we need to create a table to reference our our readers to be able to consult. So we're going to get that by going to Exploration, Descriptives, and then you take all these repeated measures variables and you plug them over into the variables list, and you're going to split this table down here, which gives you all the means and medians and minimums and maximums. You want to split all these different levels of the of the within measures independent variables. You're going to split them by gender, so you have estimates of all those different things for males and for females. Now, we don't need the medians and we don't need the minimums and maximums, but we do need the standard deviations because our table has to include both of those pieces of information. So once we ask for those different things, actually I'm going to also get rid of the ends and the missings. Once we've got this table right here, what we can conclude is that if you look at these different averages, you've got a mean for the males that are attractive and highly charismatic as 88.3. You've got a means for the females who are attractive and highly charismatic as 89.6. Their standard deviations are listed as 5.7 and 6.64, respectively. Now, this is not the best way of conveying these data, but this does give you the information that you need to be able to put into an appropriately organized table. So I will switch back over to PowerPoint and show you how you should best organize those data. So when you're writing up your conclusions for publication, to include in a journal article, the first thing you need to do is refer your reader to a table that has the means and standard deviations. And this is a better way of organizing the data than the way that Jamovi automatically output for you. But all the numbers that you needed in Jamovi are like you got them from Jamovi, and you can include them in a table like this. So the note underneath the table says that the means and standard deviations are listed in the table, and the standard deviations are in parentheses for each condition. The possible ratings of each date ranged from 0 to 100. So you can come up here and you can see that the highly charismatic dates who were attractive had a mean of 88.3 when they were rated by men, and those highly charismatic attractive dates when rated by women had an average of 89.6, and their standard deviations were 5.7 and 6.64 respectively. And those are just the same data that I walked you through in Jamovi a second ago, but I'm just showing you this alternate way of laying out the data in a table like this. So like I said a second ago, the first thing you want to do is say the means and standard deviations of each condition are listed in Table 1. Then you need to report the main effects, but if there were significant interactions involving the main effects, then we don't really spend time interpreting the main effects. We just report what they were. And the reason why we don't spend time interpreting them is because we, as I mentioned in a previous lecture, if there are significant interactions, then it's disingenuous and kind of dishonest, actually, to interpret the main effects as if they were important. For instance, in this particular situation, you recall that I didn't even ask for a plot of like just the mean differences between the men and the women, or the mean differences between high, low, and medium attractiveness, or high, low, and medium charisma. And the reason why I didn't do that was because if there were differences, and indeed we know there were, in the situations where there were differences, what would those mean? Because they depended on levels of each other and levels of gender, interpreting the raw means just by themselves wouldn't mean anything in this particular situation. You have to look at the plots of multiple variables at the same time in order to get the true full story. And so we are going to report the means and standard deviations. In the last slide, we are going to report here in this paragraph also the results of the ANOVAs and the effect sizes, but we're not going to interpret these here at the outset. So we would say something like there's a significant main effect of the attractiveness of the date on interest expressed by the participant, and then we list here the F statistic with its degrees of freedom and the actual F value. Then we put the P value after that, which was less than 0.001, and the eta squared effect, which was about 33% of the variability counted for. Then we would say there was also a main effect of the amount of charisma the date possessed, and we would list all those same things, and then we would say there was no main effect of gender, indicating that ratings from male and female participants were similar, and again, this has a p-value of greater than 0.05, and if you have a non-significant ANOVA, then you usually don't need to report also the effect size, so we don't have that listed here. After you report the main effects, next you have to report the interactions. Your goal is to help the reader make sense of these interactions by interpreting them based on how the graphs look and on any contrasts or post hoc tests that you did. Now, I didn't do any post hoc tests or contrasts, but because these graphs have error bars like this, you can kind of eyeball which ones are different from each other. Like this right here is clearly significantly higher than this one here. These two are clearly significantly the same because these error bars overlap and include the means of each other inside them. And these again are clearly different from each other. So this is the highest, this is the next highest, these two are equivalent, then it's ranked here, then this one. So you can see what's going on even though you didn't perform technically any post hoc tests. So in a real journal article, you would need to go through and you would need to compare each of these conditions to each other, but that's a level of analysis that, I mean, we already worked through that in a previous lecture, and so you could perform that, but it just kind of would bog us down at this point of the lecture to go through and show you all of that stuff. More importantly here, I just want to give you a good sense of how to interpret these interactions in a write-up that you might include for a report. So we would say something like, there was a significant interaction between the attractiveness of the date and the gender of the participant. And then you list that ANOVA output with its p-value and its eta squared, and then you would try to interpret it a little bit by saying something like, this effect indicates that the desirability of dates of different levels of attractiveness differed in men and women. The interaction graph in figure 1, and we would have like figure 1 listed here with some note about it, blah, blah, blah. Interaction graph in figure 1 shows that although both males and females' interest decreased as attractiveness decreased, in other words, the interest levels decreased as attractiveness went from attractive to average to ugly, this decrease was more pronounced for men, suggesting that when charisma is ignored, men's interest in dating a person was more influenced by their looks than women's. So the reason why I had to say here when charisma is ignored is because charisma isn't part of this interaction. It's not part of this graph. So we're just ignoring the impact of charisma, and we're saying just ignoring that overall, men care an awful lot more about looks than do women. Then we would continue on with the next interaction. We would say there was also a significant interaction between the level of charisma of the date and the gender of the participant. We would list all those statistics, indicating that the desirability of dates of different levels of charisma, again here, different levels of charisma, differed in men and women. The interaction graph in Figure 2 reveals that both males and females' interest decreased as charisma decreased. So as charisma decreased, these interest levels also decreased for both genders. But this decrease was more pronounced for females. As you see, the orange line is more pronounced, suggesting women's interest in dating a person was more influenced by their charisma than men's. So women care more about charisma than men do. There was a charisma by attractiveness interaction. And again, list that significant interaction there, the statistics, indicating that the desirability of dates of different levels of charisma differed according to their attractiveness. The interaction graph in Figure 3 reveals that high levels of charisma can make up for average looks, but that average looks cannot make up for poor charisma. So again, if you look here, you can see that high levels of charisma, that's the blue line, can make up for average looks. So if you have average looks, then you've still got high dating success. But then we also say that average looks cannot make up for poor charisma. So if you've got low levels of charisma down here, this orange line, average looks don't do anything for you. So so you can see that people are responding very differently to this condition versus this condition, which are combinations of different levels of looks and charisma. High levels of attractiveness can make up for poor charisma, though, and high charisma can make up for being very ugly. So we've just kind of also said some additional things, like that high levels of attractiveness, which are this condition right here, so these three right here, high levels of attractiveness can make up for poor charisma. Like if you've got very poor levels of charisma, you still rate pretty highly, even if even if you've got poor levels of charisma. If you're attractive, you're still rated pretty highly. And high charisma can make up for being very ugly. So if you're very ugly, which is this grouping right here, then high levels of charisma are still much better and equivalent, in fact, about equivalent to those people who are attractive dullards. So if you've got either high charisma or high looks, then you're probably going to do fine for yourself. But if you've got moderate levels of either of those things, then that's where you're going to start being questionable. Finally, there was a looks by charisma by gender interaction, and we list those statistics again. This indicates that the looks by charisma interaction described previously was different in male and female participants. Visual inspection of the interaction graphs in Figure 4 suggests that for both males and females, as dates became less charismatic, there is a steady decline in interest in dates with average looks. So you can kind of see that, like, across the board, as you move from this corner down to this corner, there's kind of like an overall downward trend. However, males are interested in attractive dates regardless of how charismatic they are. So you can see here that the three are clustered right together, regardless of how charismatic they are. For women, the opposite is true. So for the women, you look over here, and all three of these points are very high. For anybody with high charisma, you enjoy the date regardless of whether they're attractive, average, or ugly. It doesn't matter. They're all enjoyed equally well. Coming back, we see that women are interested in very charismatic dates and uninterested in dullards, regardless of how attractive they are. Now, I could go on, I could say some additional stuff like I did with you earlier about this graph and about interpreting these findings, but that gives you a good sense for how you might describe, how you might write up some of the kinds of things that I'm expecting that you will interpret when you find significant interactions in your own research studies.